Number 13 is asking us to find each product or quotient. So each answer to any multiplication problems or division problems that they throw at us. Part A is going to be 15 times, yes, that little dot means multiplication. So it's 15 times a negative 8. All right. When we are multiplying and dividing any integers, remember the first step is to just do the multiplication and division like normal, and then add the correct sign back in later. So we have a 15 times our 8. 8 times 5 is going to be 40, and 8 times 1 is 8, plus 4 is going to be 12. So I have 120 as my answer to that multiplication problem, that product. However, now I have to go back and look at the signs of the original numbers to see what the sign of my answer should be. If I ever multiply or divide numbers with the same sign, my result is going to be positive. If I multiply or divide numbers with different signs, my answer is going to be negative. So in this case, I am indeed multiplying numbers with different signs. One is positive, one is negative. So my final answer for part A is going to be a negative 120. Part B for problem 13 is interesting because you have a negative 1 times a negative 1. So it's negative 1 times itself. Now this still follows the normal rules for multiplying and dividing integers, even though they are the same number and even though the number is 1. So I do the multiplication, because again, that little dot means times, even though it looks kind of like a clover right now. So we do our multiplication like normal, and then we'll go back and add the sign later. So we do 1 times 1, which is, what? It's still 1. Amazing. Okay. And just to remind you, if we're multiplying numbers with the same sign, it's going to be positive. So I have a negative and a negative. Those are indeed the same sign. So even though I started with 2 negatives, my final answer for part B is going to be a positive 1, or you can just write 1. So this is an interesting problem because this is what they call one of the identities. It's a special problem in that it seems very simple, but is very foundational to the rest of multiplying integers. Okay, moving on. Part C has us dividing. It has us taking a 66 and dividing by a negative 2. Again, with integers, or really any numbers, when you have two numbers with signs or some negative thrown in there, you can do the multiplication and division like normal, and then go back and add the correct sign later. So we have 66. I like to use the little house method for my long division. I'm going to divide it by 2. 2 goes into 6 3 times, because 3 times 2 is 6. I drop my other 6 down. 2 goes into 6, again, 3 times, because 3 times 2 is 6, with a remainder of 0. So it goes in evenly 33 times. So now I can go back and look at my signs. I have 1 negative and 1 positive. So I am dividing numbers with different signs. So my final answer is going to be negative. So for part C, our answer should be a negative 33. Part D is a negative 45 over a negative 15. Now I mentioned in class, this fraction bar also means division. That fraction bar means division, so we can rewrite this problem if we wanted to be negative 45 divided by negative 15. These two things mean the exact same. They're just written a little differently. It's like written in a different language. So like English and Spanish, you can say hola or hi, and they mean the same thing. They're just spelled differently because they're in different languages. But they still just mean hello. Okay, so part D, we have 45 and a negative 45 divided by negative 15. We can do our division like normal, and then we will go ahead and go back and add the sign in later. Now 15 does not go into 4, but it does go into 45 a total of 3 times, because 3 times 15 is exactly 45 with a remainder of 0. So my answer is going to be 3, and the sign of that answer is going to be determined by the sign of my original numbers. My original numbers were negative and negative. So that means I've divided numbers with the same sign. So that means my answer is going to be positive. So my answer for D is going to be a positive 3, or just 3. Now you can write it as a 3 over 1 if you just chose to simplify the original fraction, but these two actually mean the exact same thing. So, I mean, either one is correct. It just kind of depends with what method you started with, or what division symbol you used at the beginning. Part E is a negative 3.6 divided by 2. So we're just doing our division like normal. We will go back and add the sign later. So we have a 3.6 divided by 2. 2 goes into 3 one time, because 1 times 2 is 2. So 2 does not go into 1, but if we drop down the 6, 2 does go into 16 8 times. Now, when you are dividing fractions, this little decimal point, I want you to treat it like a rubber ducky. Yes, that sounds very strange, but you know how when you have a duck, and that's a duck, and it's sitting on the water, it's floating, it pops up if you hold it underwater. The decimal point does the same exact thing. It pops straight up. So it is going to land between the 1 and the 8, but it pops straight up from inside the little decimal house. So now that I have found my quotient, my answer that division problem, I can go back and add the sign in. So I have one original number that was positive and one that was negative. So I have divided numbers with different signs. So that means my answer is going to be negative. So my final answer for problem E is negative 1.8. Make sure you have the decimal point in the right spot for that. 13 part F has us writing a 3/5 times a negative 4/9. Okay, again, this little dot, multiplication. You can rewrite it that way if you'd like, but that's just what it means. All right, when we are multiplying fractions, it's nice because we get to just multiply straight across, both on the top and the bottom. So if I do that, 3 times a 4, well, okay, let's rewrite it without the sign so we can officially ignore it. So the 3 times the 4 is going to give us 12 on top. 5 times 9 is going to be 45. Okay, now I have to go back in and add my sign though. So there are no signs on the bottom, and that is a good thing. It makes it a little easier for us. So we just got to look at the tops. So we have one that's a negative and one that's a positive. So I have just multiplied numbers that have different signs. So that means my answer is going to be negative. So my final answer for part F is a negative 12 over 45. So a note about notation with this though, if you wrote a negative 12 over 45, that actually means the same thing as negative 12 over 45. Those mean the exact same thing, so it doesn't matter how you write it. All right, part G has us doing 3 divided by 8. Now, it looks simple at first until you realize what the numbers are. You're like, oh, wait, 3 smaller than 8. This should be interesting. So we have 3 divided by 8. Well, 8 does not go into 3 at all. So when you have something like that, you have to add a decimal point and add a 0 so that you can continue on with your division. So 8 goes into 30 3 times, because 3 times 8 is 24. So I then subtract and I get 6, and 8 does not go into 6, so I have to add another 0 and drop it down to get 6. Now 8 goes into 67 7 times, because 7 times 8 is 56. I'm going to do my subtraction again. 8 does not go into 4, so I'm adding another 0 and dropping it all the way down. 8 goes into 40 exactly 5 times, because 5 times 8 is 40. So I would get 0. Okay, but now I have added this decimal point. So now I have to, again, you treat it like a rubber ducky. And I know that sounds kind of silly. However, it's effective. So the decimal point pops right out of the lovely division house. So it has popped straight up to be up there. Now that you have done your division, you can look back and see the signs of the original numbers. This is positive, this is positive, so my answer is going to be positive as well. So my final answer for G is going to be a positive 0.375. Now, you don't necessarily need this 0 right here, but I really like writing it there because it shows that it highlights the decimal point in and of itself, so you don't lose it. Last but not least, part H. We have a 2 1/3 times a 4/5. Now, remember when we were talking about mixed numbers the other day, that we cannot do anything until this mixed number is changed into an improper fractions. So mixed numbers are really only for answers to make them look pretty. So to change this to an improper fraction, I first have to multiply the number, the large whole number, by the denominator, which I get 6. And then you have to add it to the top. So you have 6 plus 1, which would be 7. You then rewrite with the original denominator. So my improper fraction is going to be 7/3. So let's go ahead and rewrite this with my new improper fraction. 7/3 times 4/5. Now, again, with fractions, it's super nice because you just multiply straight across. So 7 times 4 is going to be 28, and then 3 times 5 is going to be 15. Now, there are no signs involved or whatnot, and so I'm just going to keep it as my final answer, 28/15. So just to recap, part A, the answer was -120. B, the answer was 1. C, the answer was -33. D, the answer was 3. E, the answer was -1.8. F, the answer was -12/45. G, the answer was 0.375. And for H, your answer is 28/15.